Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Maisarah binti Rusidin from class ECG263. In this video presentation, I'm going to present about my mini project. In this mini project, 5 different experiments are carried out in order to study the characteristic of soil. All of these experiments are water content, particle density, particle size grading and texture, field density, and permeability. The first experiment that I'm going to explain is about water content by using the oven drying method. This water content test is the method of measuring the quantity of water contained in soil. It can be defined as the mass of water per unit mass of a dry material. The oven dry method is a standard method that has been used in this test. This is all the material we need for this test. A weighing scale, 3 sets of 3, gloves, scraper, shovel. First, the soil sample is prepared. For this soil sample, I use spark soil at my backyard. To prepare this soil sample, first use a hoe to dig the ground. Then transfer the soils into the bucket by using the shovel. Weight the empty container as M1. Transfer the soil sample into the empty tray. Spread the soil evenly by using a glove. Weight the tray filled with soil sample as M2. Repeat this step for other two parts of the sample. This is to get the average value for this test. Place the tray filled with soil into the oven and place it for overnight. As a result, this is how our samples looks like. After place it overnight, our bud soil is now known as dry soil. The dry soil is then weighed by using weighing scale and known as M3. This is the water content determination that has been obtained in the expected result. For discussion, the average value of water content is 17.31% in the range of 16.99% to 17.64%. The classification of soil can be classified as in the dry condition due to the amount of moisture lost. For the precautions, ensure that the soil sample was placed in the oven for exactly 24 hours. This is because a slight difference in time will affect the mass of the dry soil afterward. In conclusion, it has been concluded that the average water content of the soil sample can be achieved, which is 17.31%. The objective of this laboratory test can be said as achieved as the value of water content and the average water content is also achieved. The second experiment that I'm going to explain is the particle density. This particle density test is the method of measuring the particles which make up the soil mass. It can be defined as the mass of soil solid per unit volume of soil solids. The pygnometer is a standard method that has been used in determining the specific gravity of a soil. This method uses vacuum to remove air bubbles from the sample. This is all the material used: a glass jar, a soil sample, weighing scale, a jug of water. First, set the weighing scale at 0 to avoid error. The empty glass jar is weighed and recorded as M1. The weighing scale is set at 0 again. And pour the soil sample into the weighing scale. For this test, I use 200 grams of soil. Next, transfer the soil sample into the empty glass jar. Ensure that the soil is not spilled out from the glass. The glass filled with soil is then weighed and recorded as M2. Fill the jar with water and then shake it. Repeat this step several times. This must be done carefully to avoid water from overload. Then, close the cap jar. Ensure that the cap jar is closed tightly. The glass jar is then being shaken again. Place the glass jar into the vacuum for 10 minutes. This is to eliminate all the entrapped air bubbles in the glass jar. After leave it for 10 minutes, first take the glass jar out of the vacuum. The glass jar filled with soil and water is weighed and recorded as M3. The glass filled with soil sample is cleaned until there is no any residue left in the jar. The glass jar that has been cleaned is filled with water. The mass of the jar filled with only water is weighed and recorded as M4. This is the expected result that has been obtained for the particle density test. For discussion, the average value of specific gravity is 2.21 in a range of 1.79 to 2.54. For the precautions, ensure that the vacuum machine is used. This is to eliminate and throw bubbles inside the bottles that will bring to inaccurate result. In conclusion, it has been concluded that the average specific gravity of the soil sample can be achieved, which is 2.21. For the objective in this laboratory test can be said as achieved, as the value of the specific gravity and the average specific gravity is also achieved. For the third experiment, I'm going to explain about particle size grading and texture test. This particle size grading and texture test is the method of determining the particle size distribution and different grain size of soils. The sieve analysis is one of the standard methods that has been used in this test. This is all material used: weighing scale, a soil sample, tray as a pen, DIY sieve. For the largest sieve, the size is 15 mm, second largest is 12 mm, and the third one is 5 mm, while the smallest one is size of 1 mm. The initial mass of the dry soil is weighed by using weighing scale and the weight is recorded. Transfer the soil into empty container. The DIY sieves are arranged according to their size from largest to smallest. The dry soil is slowly poured on the sieve and covered with a tray underneath the DIY sieve. Ensure that the process is done carefully to avoid spillage of the soil sample. Shake the sieve to make it easier for the soil to pass through. As a result, this is how much the soil retained in the tray. By using a brush, the soil retained is transferred to the empty container, and then the mass of retained is weighed and recorded. Next, repeat the steps with the second largest of the sieve. As same as previous step, for the third largest sieve, the same steps as a previous one is repeat. Lastly, for the smallest sieve, the procedure need to be done carefully as the size of the sieve is very small. Use a brush to make it easier for the soil to pass through and shake it a little bit. This must be done carefully to avoid any spillage of the soil. As a result, this is how much residue left, and this is how soil retain looks like. The soil retain is transferred into the empty container, but first the weighing scale must be set at 0 to avoid any error in reading. Then the mass of soil retain is weighed and recorded. As a result, this is how the residue left looks like after the dry sieve test. This is the grading curve that has been obtained from the expected result in this test. For discussion based on the result, the soil can be classified as well-graded very sandy gravel, as the highest composition of the soil is gravel, which is 65.13%. For the precautions, ensure that the sieve size is arranged in order, as the slightly difference in mass will contribute to inaccuracy in results. In conclusion, it has been concluded that the classification of the soil can be achieved, which is the soil can be said as well-graded very sandy gravel. The objective for this laboratory test can be said as achieved, as the classification of the soil can be identified. For the fourth experiment, I'm going to explain about field density test. This field density is the method of determining field density of the soil and can be defined as a mass of unit volume of a material substance. The sand replacement method is the one of a standard method that has been used in this test. This is all the material used in this test: weighing scale, shovel, brush and scraper, knife, tape and scissors, soil and 2 plastic cups. Make a calibration cylinder, you need 1 plastic cup and a plastic cap. Next, to make a calibration cylinder, you need 1 plastic cup and 1 plastic bar. As you can see, this is how my calibration cylinder looks like. Next, to make a tray with hole, you need to cut in the middle of the tray. So this is how metal tray with hole looks like. First, pour salt into the sand pouring cylinder. Fill the sand pouring cylinder until full. By using the scraper, spread the soil evenly until it becomes flat. Next, weigh the mass by using weighing scale. To do this, set the weighing scale at 0 first, and the weight is recorded and known as W1. And then put the sand pouring cylinder on top of the calibration cylinder. Then open the shutter to allow it fill the calibration cylinder. The excess residue on top of the calibration cylinder is known as heap of sand. This calibration cylinder is used to determine the density of the sand. Weigh the mass of sand pouring cylinder that the shutter has been opened previously and recorded as W2. Place the sand pouring cylinder on top of the glass plate and open the shutter again. The mass of the heap sand is weighed by using weighing scale and known as W3. Fill the sand pouring cylinder again and this is recorded as WN1. Clean the fill area by using the shovel. The metal tray center hole is placed on the prepared surface. The soil is excavated by using the shovel to require depth. The excavated soil is then poured carefully into the empty container. The mass of excavated soil is weighed and known as W excavated soil. The excavated soil is placed into the oven for drying. After oven drying method is done, weigh the soil again to find the moisture content. The sand pouring cylinder filled with sand is placed on the hole. The shutter is opened to let the sand fill the excavated hole. The shutter is closed before weighed by using a weighing scale and recorded as WN2. This is the expected result that has been obtained from the field density test. For discussion, the value of dry density of in situ soil is 1461.06 and it can be obtained from the value of bulk density and the moisture content. For the precaution, ensure that all the equipment are in a correct state before take a reading. For instance, before using a weighing scale, the reading is set at 0 first. This is to eliminate zero error that may occur during the test. In conclusion, it has been concluded that the dry density of in situ soil can be achieved by using the values from the bulk density and the moisture content. The objective of this laboratory test can be said as achieved as the value of dry density, bulk density, and the moisture content of in situ soil is also achieved. For the last experiment, I'm going to explain about the permeability test. This permeability test is the method of measuring the ease of movement of fluid and gas through the open space. It can be defined as the rate of flow of water under laminar flow. The falling head method is a standard method that has been used in this test. This is all the material used in this test: a jug of water, soil sample, empty water bottle, and a weighing scale. Before conducting the test, we need to prepare all the equipment. Label H1 until H4 with a different height but same distance between each other. Then make a hole at the bottom of water bottle using a knife. The labeled water bottle is put in the empty container. Pour the soil into the water bottle carefully. Ensure that the soil is not spilled out from the bottle. For this soil sample, I used 200 grams of soil. The soil is then being compacted by using a wooden stick. This is to eliminate all the air voids between the soil particles. The water is then poured into the water bottle until it reaches more than line H1. Set a timer once the line of water reaches H1. It may take a while for the water to drain out from the water bottle until reach H4. Stop the timer once it reaches H4. As you can see, this is how long it takes for the water to drain from H1 to H4. This is the expected result that has been obtained in this permeability test. For discussion, overall average coefficient of permeability of soil sample is 1.854 exponent -6 meter per second. Can be classified that the soil type is a silty clay and high permeability and also in a poor drainage condition. For precautions, ensure that all the equipment are used correctly as the entrapped air bubbles occur in the step pipes will affect the reading. In conclusion, it has been concluded that the overall average coefficient of permeability of soil sample can be achieved. The objective of this laboratory test is also can be said as achieved, as the coefficient of permeability of ground soil also achieved. That's all from me. Thank you for watching.